Okay, so we're going to continue learning about chemistry, and now we're going to talk about chemical equations and energy. And so chemical equations is almost like a math problem where you can take two things or three things and add them together and get a new result, and you can take whatever that is and break it down. And the process of making things and breaking things also helps you store and release energy. So that's when we're going to kind of cover what a reaction is and what happens, where the energy goes when you make and break different products. We talk about chemistry, especially biologic chemistry like proteins and how you're making sugars and the things that we use in our body. So we're going to just do some basic chemical reactions and talk about where that energy is stored and where it goes. Okay, so when you talk about a chemical reaction, you have your reactant, which are the things you're going to put together, and then the product, which is the result, what you're going to get. And so in this example, you have a hydrogen atom plus a hydrogen atom, which gives you H2. Remember, that's a molecule. If you have two of the same atoms added together, you get a molecule. So this is hydrogen gas. Another example would be 4 hydrogens plus carbon. You get CH4, which is methane gas. This would be a compound. So we've already talked about some of these before. I'm using the same examples so that hopefully you'll start to have that drilled into your head now and understand and remember some of these molecules and compounds. So hydrogen gas and methane are examples of some chemical equations. So when you put things together, you form bonds. And in some chemical reactions, you may rearrange bonds. You may even break bonds. So any kind of chemical reaction can make stuff, you can rearrange stuff, you can break stuff. And those are all examples of chemical equations. And I'm going to give you several specific examples as we move through this. So if you talk about chemistry, you have to talk about energy because the making and breaking of bonds is all about storing and releasing energy. And so what is energy? Energy is the capacity to do work or to put matter into motion. And there's two types of energy, kinetic and potential. Kinetic is energy in action and potential is stored energy. So the old rubber band. If I pull this rubber band back, it has the potential to do something. I've stored up the energy. It's inactive, nothing's happening, but if I let it go, kinetic, energy in motion. Potential, kinetic. So stored energy, active energy. It's easy to understand, right? Yeah. So there are different types of energy that we use every day. We have chemical energy, electrical energy, mechanical energy, and radiant or electromagnetic energy. And this is energy that we're able to use in our bodies all the time. Chemical energy, we've talked a lot about bonding. That's the energy that's stored in bonds. So for example, we're going to talk about something called ATP later on, and when ATP is broken down, it releases energy, and that's the energy that we use to move our muscles and things like that. Electrical energy. Our nervous system uses electrical energy. Just like you have electricity running down a power line, electricity is the movement of something that's charged. And so your nerves, they basically run by allowing charged particles, sodium and potassium, to kind of move and flow down the axon or down the long nerve. We'll get to all the terminology of it later. But the nervous system basically uses electrical energy. You have a mechanical energy, which that's the energy that you use to move something. So to physically move, that's mechanical energy. Your heart pumping, moving blood through your body. And then electromagnetic energy. So for example, the visible light. So light will bind and cause the receptors in our eye to respond, and that's how we see. So we need visible light for vision. And we also use UV light. UV radiation, when it hits our skin, it starts a process that helps our body make vitamin D. So we use all four of these types of energy every day. Energy can be converted from one form into another. So you can turn electrical energy into radiant energy. So example, a light bulb. And when you convert energy from one form to the other, you always lose something. It's not very efficient, and you always lose something. And that energy that you lose is usually heat. So for example, a light bulb, if you have a lamp and you turn on the electrical energy, flip on the switch, and then the light bulb comes on, the radiant energy, what happens? That light bulb gets hot. Okay, the light bulb gets hot. That heat is the energy that's lost in that conversion of electrical energy to radiant energy, okay? And that same thing happens in us, in our bodies. When we convert chemical energy, the bond energy, into mechanical energy, so when we convert, say, glucose into the energy that allows our muscles to move, there's a long process making ATP and stuff like that, but just think right now, turning basically glucose into moving your muscle. When your muscle moves, you generate heat. One of the ways our body stays warm is by muscle contraction, and that's just a conversion of that chemical energy, bond energy, to mechanical energy, and the result is that we get body heat. So you always lose energy as you convert from one form to the other. When you talk about chemical reactions, we have some new vocabulary we're going to learn. We have the word exergonic and endergonic and catabolic and anabolic. So these are 4 words you need to store in your memory. Exergonic, so ex means like to leave, so like to exit. So exergonic is to release energy. And anything that's an exergonic reaction that releases energy is going to be a catabolic reaction. And catabolism means to break things down. So to take a large molecule and break it down into something smaller. Endergonic, like coming in, endergonic means you're making something. All right, so the products contain more potential energy than the reactants did. You're storing up energy. And so an anabolic reaction is when you make stuff. So an easy way to remember this, a lot of people have heard of anabolic steroids. So people take them and they get all buff and they build muscle. So anabolism, anabolic, to build, those are endergonic reactions. Exergonic or catabolic or catabolism is to break things down and release energy. Okay, so I'll use these words from time to time, so now you know what they mean. The big thing about this class, as you'll understand, is the tests are all about using the vocabulary words as parts of the questions. Your exams are not necessarily define the terms. I use the terms in order to write the question. So you have to know what the terms mean so you can read the question so that you can then answer the question. So vocabulary is very important in this class. Make sure you learn all the terms that I point out to you. Okay, so one of the first types of reactions we're going to talk about is a synthesis reaction. So when you synthesize something, you make something. So this is when you take something small and make something more complex, make something big. So A plus B, 2 small somethings make a big something. So this is making a bond, this is anabolic, and this is storing energy. So an example of that would be to take amino acids. If you take those and add those together, you get a protein. So a protein is simply a long chain of amino acids. Another thing that you can make is if you take a bunch of glucose molecules and add them together, you get something called glycogen. And glucose is the sugar like in a candy bar, and we can turn that into glycogen, which we store in the liver so we can use it later when we need it. Okay, so to synthesize something is to take small particles and make something big out of it. You can decompose that. So a decomposition reaction is when you break things down. You break those bonds. You take the big stuff and make it small. So I just told you about glucose makes glycogen. You can take glycogen, now that you maybe need some energy, you need to release that glycogen and get the glucose out of your liver, you break the glycogen down into glucose. So you take AB and break it down into A plus B. Breaking those bonds through catabolic, releasing energy. Okay, so synthesis and decomposition. The third type is an exchange reaction. That's where you take 2 things and kind of rearrange them. So, for example, AB plus C, you rearrange, put the A and the C together, now you have AC plus B. This is called a displacement reaction. So you're actually breaking that bond but making that bond. Okay, so you're both making and breaking bonds. So example of this is when you're making ATP, breaking it down into ADP. We'll talk about this when we talk about muscle contraction later on. But if you have a glucose molecule, this is what it looks like chemically in an ATP. You can break that bond, take this P off, and add the P over here to this glucose. So now you can see you've made a new product here, and this reactant is a little bit smaller than it was before. So you've just kind of exchanged things. So you can call it a displacement or an exchange reaction. And we'll have several examples of those throughout the semester too. I just want you to know if I say synthesis, we're making, decomposition, we're breaking, exchanging, we're rearranging. Okay, so that's kind of our three types of chemical equations we'll focus on this semester. Okay, so the last thing I want to talk about are how do you increase the rate of a chemical reaction. So chemical reactions, they occur at a certain speed, and you can speed this up by doing certain things. And so this is important because imagine if you want a reaction to occur, you need it to occur now. You don't want to wait days or weeks or months. Think about digesting your food, or making proteins or building muscle. These things need to occur in a timely manner. They don't need to take all day or all week or all month. You need to be able to speed things up a little bit. So in a general reaction, you can speed the rate that a chemical reaction occurs by doing usually one of three things. You can either increase the temperature, decrease the particle size, or increase the concentration of the reactant. And so the best way to understand this is to think about making iced tea. Okay? So if you're from the South, you know what I'm talking about. So if you're not from the South, you're about to get a lesson on how to make iced tea. And so to make good iced tea, it's got to be sweet. It's got to have sugar in it. So what we want to think is, what can we do to get that sugar to dissolve, to make that tea sweet fast? What's the quickest way to make iced tea sweet? So the first thing you can do is you can increase the temperature. And that will increase the rate at which the sugar dissolves and the tea becomes sweet. We all know that sugar dissolves a whole lot faster in hot tea than cold tea. So the first key to making sweet tea is add your sugar when the tea is still hot. Increase the temperature, dissolve the sugar faster. The next thing is you can decrease the particle size of the sugar. So if you want the tea to become sweeter, do you add a large block of sugar, or do you add granular sugar? Granular sugar. The smaller the sugar particles, the faster they'll dissolve, the faster the sugar will become sweet, the faster that reaction will occur. If you want it sweet, it's easier to make it sweeter by adding more sugar. So the higher the concentration, the more sugar you add, the faster the reaction will occur, the sweeter it will become. So the more sugar you add, the higher the concentration. So this is how you can influence the rate of a reaction. You can increase the temperature, decrease the particle size, or increase the number of particles, or the higher the concentration of the reactant that you're using. Now, that's not always biologically feasible. My body temperature is 98.6, and so if I need my reactions to occur faster, I can't necessarily just increase my body temperature, okay? I need all of my reactions to occur at that temperature without it changing. I don't necessarily have the ability to change all my particle sizes either. So if I need things to be made, glucose to turn into glycogen and amino acids to turn into proteins, I can't necessarily make my amino acids smaller. I need these to occur at the size that they're at. And I can't necessarily increase the concentration that I have. So what I need is a catalyst. I need something that's going to increase the rate of reaction without me having to do any of those three things. And so a catalyst is something that will increase the rate of the reaction without having a chemical change. So think about adding gasoline to a fire. That's kind of like a catalyst. But for biologic systems, the catalysts that we use are called enzymes. And enzymes are biologic catalysts. They're things that will increase the rate of the reaction without actually changing themselves. Okay, so an enzyme, so it's like this is an enzyme, and say it's got a goofy little shape, and so I want to make this, and I want to break it down into little bitty parts. Let's say it's a protein like steak. Let's imagine it's steak, and so steak's made out of protein. If I eat that steak and it's sitting in my intestines, it could sit there all day and not do anything until an enzyme comes in, a protease. So anytime you see the word ACE, the last three letters ASE, that's an enzyme. A protease breaks down protein. This enzyme will come in and start breaking down that steak for me because the steak's made out of protein. Steak has fat on it as well. And so I might use an enzyme called a lipase. Again, see that ASE? That means it's an enzyme. Lipids are fats, so the lipase would come in and help me break down the fat part of the steak. So enzymes are biological catalysts that we use to help us break down things or increase the rate of the reaction. And again, they always end with ASE. We're going to learn one called acetylcholinesterase. That's a long one, but we'll learn that one later on in the semester. So anytime you see ASE, that's an enzyme, a biologic catalyst that's being used to increase the rate of a reaction. I've got a short film I want to show you, and then I'll see you on the other side.
An enzyme is a protein that changes the rate of a chemical reaction without itself being changed into a different molecule in the process. Enzymes promote and regulate virtually all chemical reactions in cells.
All right, that was just a quick little video on enzymes. We'll study enzymes again as we move through the semester, but just remember to learn the different types of reactions, the kind that make things, the kind that break things, and the kind that rearrange things, and how that stores or releases energy. Thanks a lot.